Okay, so we're talking about logs. We're telling you the rest of the story on logs. So far, we just started with something simple like this. 5 to the x equals 8. We said, oh, you can rewrite that. You can rewrite that as a log. I'd like you to try right now. Okay, later. Put that away. Okay, rewrite that log, please. Okay, learn right now. Take notes. All right, this is an exponential. Log starts with the word log. And since this has a base of 5, our base of our log is 5. Log base 5 of 8 equals x. All right, so there is a log now. But, and what we had a lot of times is we would be putting in, oh wait, let's talk about how you can put that in. You can put that in as log 8 over log 5 on a calculator. Okay, remember that? Log 8 over log 5. All right, now, what you're going to learn today is a lot more stuff than just, oh, if we put a 5 here, what's the answer? 1. If I make this 5 cubed, what's the answer? 3. Okay, you're going to learn a lot more than that. All right, I'd like to begin with this. Log 2 plus log 3. I'd like you to figure out what log 2 is on the calculator. Grab your calculator, type in log 2. It'll be a decimal. Give it to me in three places and write it down in your paper. If you don't have a graphing calculator, borrow one from me. Please do not just sit there and figure out how many loose split ends you have on your hair or whatever. Get your calculator out or borrow one of mine. Okay, here we go. Log 2. What is it? What decimal? Point what? 301. Thank you. What's log 3? 0.477. Now, where's the log button? That's a little scary. On the left-hand side, about halfway down. All right. Now, would you agree that 0.301 plus 0.477, I mean, this is this, and this is that. Now we're supposed to add them, right? So that's 0.7 and 78. You get how that's 0.778? Just add them together. Now, couldn't you have just done log of something else and get? Log of 5 seems logical, but it's not log of 5. It's log of 6. What's the interesting takeaway? I hope this is interesting to you, that you could take this 2 and this 3, and if you're adding them like this, you do not add the 2 and the 3. You multiply the 2 and the 3. So here is the thing that's the property that I need to have you write down that you now hopefully will understand better. Log x plus log y is equal to log of, what did we just figure out? X times y, or xy. You get that? So if you take two logs and you add them together, you can condense them down into just one log. See how this is a big long thing and this is condensed down? Get used to those words. There's condensed and then there's uncondensed. Do you know what the opposite of condensed is? Not uncondensed. Expanded. Okay? So there's expanding logs and condensing logs. What we just did is we condensed this log down into log 6. Instead of log 2 plus log 3, it was log 6. Instead of log x plus log y, you could say log xy. So instead of doing this problem the long way, do it the short way. What's log of 5 plus log of 7? Don't use your brain, use your calculator and type it in, and you should be able to just do it really fast with one log. What are you going to do? Log of what? Log 35, and what is it? 1.54. Could I have found them separately and added them together? Sure, but it's a lot faster if you know that when you add them, you really can take these two parts, the argument, put them together, and multiply. All right, but what happens if I'm subtracting? I won't make you go through the whole explore it on the calculator thing, but I'll let you guess. What if I have log 5 minus log 2? Want to take a guess? It's not log 3. Yes, so it would be log of what? Log of 5 over 2, you got it. If it's a subtract, you can condense it down into one log and make it a divide. Like that. So if I want that in a XY thing, I would say log X minus log of Y, the log of X over Y. These are important little rules you are writing down and learning right now. We're taking notes on this, so writing it down gives you like a much, much better chance of remembering. It's just a fact. You think you're going to remember it, but taking that extra piece of picking up your pencil moves your brain into a different area of your brain. Just listening, or your finger, just listening activates only one part of your brain. That part of your brain, not so good at remembering. Now, can you remember something? Yes, if you by just listening, but it's usually based on having like something really scary happen to you. Your emotions would have to be really high. And then all of a sudden, yes, I was thinking about scaring you, but I'm not going to because I'm recording. So, anyway, if you do something really crazy, then the person is much more likely to remember the situation. Okay, so if I were, for instance, wearing all spandex and standing on that table and saying something, you'd probably have it scarred into your memory for years. I'm not going to do it. Okay. Now, of course, there'd be some sort of lawsuits involved, probably, so it wouldn't be worth it. All right. So, I'm going to tell you another one that you probably didn't know. That if I have something like this, you do know this one. If I have log base 5 of 5, it's 1, right? And if I make that a 2, what's the answer now? 2. Do you get how then it's just as if I take this 2, and I'm saying it's 2 times bigger than it was, right? Because the answer was going to be 1. But when I slapped the 2 on there, it got twice as big. I can put the 2 there instead. Right? Cerebral cortex. So I can take things that are squared over there and drop the 2 in front. Why? Because what's that equal to? 1. 2 times 1 is 2. It's still the same answer. It'll work for anything, and therefore you can do that. And that's actually expanding something. So what if I had log of xy squared? I could expand it. So I could take the log xy squared. This is a typical test question. It's at R2 level. It's an easy one because you're just learning it. We'll get to the harder ones like tomorrow. But if I had to expand this out, first ignore this squared for a second. Just how would I expand that part out? Yeah, log x plus log y. Simple as pie. But then this little 2 here, this little squared, do you get that that little squared is still here? And now how can I expand this out even a little bit further? Put it in front there. Yep. That's all the way expanded. All right. And what if it was like this? Couldn't that be expanded out to something really beautiful? Give it a shot. See if you can figure it out. I'm guessing I'm going to go with less than half the class did this one, right? See if you're in the top half of the class. Yes. Yeah. Yep. Okay, how about if I come back to that? For right now, I'd like you to try this one. I will come back to that question. It's a good one, but I've got everybody working on that now. All right, your first thought should have been, you can actually do it 2 different ways. I'm going to take this divide off of here, and I'm going to make it log x squared y, and instead of divide, remember how I can make that a subtract? Log c. I got the divide out of there and made it a subtract. Now I'm going to get this multiply out of here and make it into an add. Log x squared plus log y, and then I still have minus log c. I'm not trying to condense down, I'm trying to expand it out. And then there's one last thing I can do. A little 2. Just take this little 2 and put it in the front, and there we go. That's expanded form. How many had it right? Top half class, way to go. Okay. Let's have another like that. What do you think would happen if it was ln? It'd just be different in that the answer will be in an ln. So ln of, what do you think? X over y. Change to minus, to a divide. That's it. So it works the same exact way with ln. The ones we were doing before, I was just saying log, so we were assuming a base of 10. Now at the base of e, doesn't matter. Same rules work in base of e. All right, here's another one. Prepare for cerebral cortex destruction. Do you know I can multiply both sides by anything? Right? I can add both sides. I add like 5 on both sides. I can do that, right? I can square root both sides. That's true. What do you think I'm going to do? Nope. 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 What's this lesson been all about? Fun out logs, yes. So, very good. I have this weird feedback noise in my class. I think it's my iPhone trying to. I got it programmed to. Yeah, anyways. Okay. So, alright, you're not obviously going to get this one on your own. So, I am going to, if I was hinting about doing things to both sides, the lesson's about log. Maybe I could do log on each side. Yes, so I can take a log on both sides. It can go log of this side and log of that side. But what kind of a base should I use? Since I can use any base I want. I'm smart about it. Yes! Because then, think about this now. Do you get how this part right here, the answer equals that? All of a sudden it's x equals log base 5 of 20. Yeah, isn't that nice? Oh, crowd breaks into applause. Okay. Or at least one person. So, this is a technique you can use now to solve equations. You can take a log on both sides if you want. And when you do it in a smart way. All right, so let's say I had e to the x equals 20. I can take, yes, log base e, otherwise known as ln. I take a ln on both sides. And why is that smart? Because this is really log base e, and therefore this becomes just x. X equals ln of 20. All right, so you can take the log of both sides. All right. How about this? Let's see if you can handle this. Log of 5 plus log of 5. What does that really equal? Log of what? 25, because add turns into multiply. And what's 25? Log of 5 squared. And then what could I do with that little thing? All these things that I just wrote are equal to each other. And if you think about it, log 5 plus another log 5 makes 2 log 5. Doesn't that make sense? No. All right. Typical problem is an expansion problem or a condensing problem. So let's do a typical, this is kind of on the easier end still, but see if you can handle this one. It's going to be tough. 3 ln x. What you're trying to do is condense this down to 1 log plus ln y. I'll just leave it at that. That's good enough for now. Okay, we'll get harder than that, but see if you can condense that down to just 1 log. It'll be an ln, of course. It's 3 times 3 ln x plus ln y. You can condense this down to 1 ln, yes. That means log base e. Whenever you see ln, right, log base e. You could even do it now. The point here is, do you get that I have an add here? And that the add means that I could change that to a multiply? And you get that this little 3 has another home? It shouldn't really be down in front. It should be up as a little exponent like it was when it was born. All right. So then, if if I just do that one thing, I could go like this. I'm starting to condense it down, and I've got log base e of x to the third plus log base e of y. Do I have to say log base e? No, I'm just doing that because some people aren't used to ln yet, and that's okay because we haven't been around. Now, you get that this add can be turned into a multiply, so that still got a 3 on the outside. Log base e of, I can make that a multiply, x to the third times y. Hey, I'm almost done. Now the hard part comes in with that 3. Should I just slap it on one of the two and pick one that the lucky variable gets to have the extra 3 on it? No. So you have to kind of distribute it. Or another way to think of it is log base e of x cubed times y. That's what's on the inside. Now I got the 3 off the front. Where am I going to put it? Should I put it here? Should I put it here? How about if I put it around? Raise your hand if you had that one right. So lucky 4 people. Nice work. Very good. Now, could I actually just kind of distribute this, or do this cubing here and this cubing here, and say log base e, otherwise known as ln, of x to the, what do I do when there's a power to a power? I times it. 9. And that's y to the third. Yes, you could do that. But it'd be just as good to leave it this way. I'd be fine with that. Okay? There'd be your final answer. Or you could, of course, say ln of x to the 9th y cubed. Or you could have left it like that. All right, see if that one was okay. See if you can handle this one. Or parentheses, log x plus log y times parentheses minus 3 times parentheses log y plus log z. Yep, by doing this you are doing a homework problem. You'll know what to write for that one. It can be done. You don't even want to do a problem in class because it's actually a homework question. That is so sad. You should be an insult. Because then you can be like, I really don't want to have to butter my toast. How can I get out of this room? Well, I can make this toast buttering machine so that every morning at 7 a.m. it butters toast. Of course, you go on vacation for a month and you come back to all this rotting buttered toast. But, oh, there you go. Moldy. Maybe the... All right. So, if I were you, I'd start in here, put them together. Seems like a good step. Notice we're starting on the inside. Seems like a common theme in math. That's why I often suggest you start on the inside when you have choice. And here you don't even have choice, really. Okay, so then I'm going to go 4, and then I'm going to put those together and say log xy minus 3 log yz. And now, I need to figure out what to do with these 4 in the front deal. I can put it in and say log xy to the 4th minus 3. No, wait. Let's just do that. Log yz to the 3rd. And then it can all be put together into one log. Log. Oh, and it's a subtract, basically turning it into divide. Xy to the 4th, like that. Be careful if I go into parentheses, it's wrong. Over yz to the 3rd. Done. Uh-oh. Oh, okay, so is there some simplifying? Maybe yes. Let's see. Let's actually multiply this out. Log x to the 4th, y to the 4th, over y to the 3rd, z to the 3rd. And oh, there is some y's, some sneaky little y's in there that are going to keep me. And yes, those should be canceled. So log x to the 4th, y, over z cubed. Whew. Oh yeah, 3 minutes early. Okay. That is called condensing. And you've learned a bunch of new properties about logs. So I hope that you feel a little bit smarter than when you walked in. And we can practice it on paper, which again sets it in a different place in your memory. soon. And it's very short, so enjoy a one-sided worksheet that's hopefully going to feel easy to you today. So we do have the test to hand back after lunch, but at least we're all done with this part.